the Italian perspective on this, and we will be presenting two initiatives, Paolo and myself. One is called NQSTI, National Quantum Science Technology Institute. I'll be talking about that, and then we're going to be talking about ICSC. Well, where does it stem from? It's all from the post-COVID situation in Europe. The European Union generated this program called Next Generation EU. Sizable funding correspond to that. Part of that was funneled into Italian programs, and that's what we call the Italian PNRR, and that is 200 billion euros. Out of that, we are focusing on education and research. Mission 4, which is a total of 31 billion euros. And these are programs that are around 3 years plus some extension, I assume. Out of this, is this happening? Yes. We are talking about NQSTI. So what is this initiative? Well, I guess the name says it all, right? We plan to form an ecosystem, nationwide ecosystem, where all the competence, structures, facilities for quantum science and technologies are located. This is the topic that we're supposed to handle. The focus here today is mostly on quantum information technology. I want to underline that for us, QST is larger than that. So essentially, that will be the definition that we based our program upon. So exploiting the peculiarities of quantum physics and quantum mechanics for a number of applications, any of them. Of course, a significant part of it is QIT. Our funding is 120 million, which you have just about to double considering the internal funding for the same initiatives. This program is a low TRL initiative. I will elaborate on that. That was the mandate for that. We started with a group of 20 institutions, companies, universities, research entities, with a staff of around 320 and just about the same number of hires in various shapes and forms. This is a growing initiative, as I was mentioning before, because although we are spread throughout the whole country at this point in time, we have a program to recruit more institutions through an open call system, because really we want NQSTI to be the one shop where you can find all the competence available in the country, coordination where new ideas can come up. A little bit of European jargon, we talk about hub and spoke. A hub would be like the coordination entity, the spokes would be more or less the work packages of a program. That's the official terminology that we have to use. So what do? So we have two spokes, two work packages on fundamentals, the theory spokes that I show there. The idea is this is where you put all the theoreticians, where the new ideas should come out, the new Hamiltonians, if you wish, that are of interest for all the scope of quantum science and technologies. These new ideas are then projected onto platforms. We selected the three obvious technological platforms: atom-based, photon-based, and electron-based. When I say electron-based, I mean solid state in general. It can be superconductors, can be semiconductors. You can look at the phase, at the spin, at the charge, doesn't matter. So there's an interplay between theory and platform in the sense that platforms compete to implement the theoretical ideas. That's one error. But at the same time, they stimulate new ideas from the theoreticians in order to explore all the novelty possible. The reason why we were given this low TRL target is exactly that. We're supposed to be generating new schemes, new idea, new approaches. All these platforms and building blocks then integrate in what we call Spoke 6, where the functional complete subsystems are generated, and there's an interplay with the complete system, so novelty also in architecture. This is the scope, scientific scope, if you want, but I also underline we have a program in education and technology transfer, which is one of the main reasons why I'm happy that we were given the opportunity to be here, Paolo and I, because I want to mention that in particular. So what do we do? Quantum research, of course. The idea is, as I was trying to tell you, stimulate new ideas with the funding that we have. We have selected the best labs available in the country and have completed their infrastructure. The idea is to have a forum where new ideas can develop. Outreach and education. I personally think outreach is very important because we have seen what Novax did. Well, I'm waiting for no quantum. It's just a matter of time. We have a focus on helping the generation of new companies out of this knowledge that is being developed, and we have funding for that, so to support creation of new companies. As you know, the backbone of the Italian economy is small and medium enterprises, so we have a program to bring these smaller institutions towards innovation. Joint labs, prototype production, these are all things that we have resources to support. And of course, there's collaboration with large companies whenever possible. It is particularly important for me today to mention international programs. We hope to be able to help the Italian community to be even more networked internationally. We hope to generate and co-fund joint programs. We did that at European level recently. There are European calls for the European research area. There's one scheme in particular for quantum technology. Well, we supported the Italian participation to this scheme, and the selection is ongoing right now. That's, again, one of the main reasons why I'm here, because I hope that by talking to some of you, we can come up with new ways to fund and support collaborations. We cannot fund external partners, but we can cover the Italian partner needs. And the idea is to have joint activities with the US, of course, and with all the other nationalities that are present here. So we'll be around, I'll be around this afternoon. I already have quite a few people that I'm going to meet, and I hope some of you will show up. With this, I have to stop because I only have 10 minutes, and Paolo, the clicker is yours. Thank you.
I'm a little bit disappointed because in the plenary session, there was the jingle music introducing a new speaker, so we do not have this, but in any case. And also I need some sunglasses. So I will talk a little bit about the second initiative, which is the Italian Research Center on High Performance Computing, Big Data, and Quantum Computing. And this initiative this center is managed by a foundation, the ICSC Foundation, that is the Italian Center for Supercomputing. And the center, the foundation, is based mainly on 3 pillars. So the first pillar, the first goal is that of hosting an hybrid, world-class, high performance and quantum computing system within the center. And the second pillar is to become an hub of expertise about some vertical domains that are characterized by high demanding computing requirements in different strategic domains, such as space, such as climate, environment, medicine, and other vertical domains. And the last pillar is focusing on education. And here the goal is to train the next generation of experts in high performance, and more specifically on quantum computing technologies, because there is a lack, not only in Italy, but I think worldwide, about people with this type of expertise. And the center, the headquarters of the ICSC center are located in the Big Data Technopole, which is a new high-tech district in Bologna. And within this location, we already host Leonardo, which is the 6th most powerful supercomputer in the world. And we are already planning to integrate Leonardo with a quantum accelerator based on neutral atoms. So the plans are to install this quantum accelerator within next year, hopefully, and to integrate it with Leonardo in order to build this hybrid computing infrastructure. And so differently from the National Quantum Institute, this center is focused on readiness level, on higher readiness level, from level 5, which is, let's say, technical validation, up to level 9, which is the ability to prove in an operation the validity of systems and applications. The center is founded by 51 founding members, and overall within the center there are more than 2,000 people working for the center, and out of these 2,000 people there are 500 new researchers who are working full-time for the center. And within the 51 founding members, there are 25 public universities, there are 12 public research institutions in Italy, and there are 14 private companies, and from different strategic sectors for Italy. You see the names of this company. They are covering sectors from, again, from transportation, from space, from energy, from finance, and other sectors. The center is structured, so the research activities, all the activities within the center are structured along 11 spokes, 11 research lines, and spoke 0 is responsible in providing the computing infrastructure, so the traditional high-performance computing, but also the quantum computing infrastructure. There are a number of spokes from 2 to 9 that are focused on vertical domain applications, and spoke 10 is the one that I'm co-leading, is focused on quantum computing. And overall, the center has been founded with 320 million euros for 3 years, from 2022 up to 2025. And this funding is coming from what Fabio was saying, so the PNRR, so the National Recovery and Resilience Fund. And so if you focus on spoke 10, the spoke on quantum computing, the total budget of this spoke for 3 years is more than 30 million euros. And within the spoke there are 15 public universities and research institutions and 10 private companies working for the spoke. Overall, there are more than 200 researchers working for the spoke, and almost 50 of them are full-time researchers. The activities within the spoke are structured along 3 main work streams. So we start from the hardware level, where the main focus, even if it's not the only focus, is on designing new and more efficient qubits, addressing different types of technologies, from superconducting to photonics and so on. Then we have the middleware level of activities, where again, one of the main focus is on building new emulators, more efficient emulators for quantum computing platforms. And finally, we have the software workstream of activities, and here the main goal is to, let's say, prove that it is possible to write quantum algorithms which are able to provide some sort of advantages in some specific application domains. And that's all for my part of the presentation. If beside the questions at the end of the presentation, I will be here today and tomorrow morning, so if we want to stay in contact with me. Thanks again.